Hello everyone, welcome to Algebra Made Simple. I'm your host Chris Morris. Today's topic is a very important topic because we are going to discuss a formula that's very famous. It's built off of the idea of completing the square, and it is useful when you're trying to solve quadratic functions but you can't factor it. Not all quadratic functions, quadratic equations can be factored, and we ran up against this in my Algebra 1 class I teach, and so I wanted to bring a video that I could use for the world, but also a video I could use for my Algebra 1 class, so students pay attention. Sometimes you'll notice that you can't factor a trinomial, for example. Let's go ahead and bring on the screen and I'll tell you what it is that I'm talking about. So like right here, we have an example of one that does not factor. If you're wondering what I mean by does not factor, well, let me just go ahead and tell you. When we try to factor, typically we're looking for two numbers. You do your parentheses like this. Okay, let me see if I can blow this up, make it a little bigger, right? And you usually got that x squared, so we'd say put the x's in each spot, right? Well, then you start asking yourself, okay, what are two numbers that multiply? I'm going to do my little ugly time symbol here. That's as good as I can do. All right, that multiply to the outside number. That would be -7 in this case. All right, but at the same time, you need those same two numbers. If you were to add them, they have to add to the inside coefficient. In this case, it would be +4. So if you're wondering where I'm getting that, I'm looking at the -7 here. Two numbers have to multiply to -7, but they'd also have to add to +4, and that's how you're taught how to factor these quadratic trinomials. Well, there's a problem here. I'll give you a second to see if you can spot it. Oh, wait a minute. The only thing that multiplies to -7 is 1 times -7, right? Or you could do the other way around, -1 times +7. But the problem is there's no way that you could add 1 and -7, for example. That's not going to add to 4. Doesn't work. That adds to -6. It does multiply to -7, but it has to check both boxes, right? It has to check both boxes. So you can't solve these types of quadratic functions by factoring. If you don't have a graph available to you, it's very difficult to find the x-intercepts or the zeros. Now, I just want to show you something just to prove that there are x-intercepts here. So I'm going to switch the screen over to Desmos.com, and I plugged in the same function, x squared plus 4x minus 7. Remember, the solutions, the zeros, the x-intercepts, those are all the same thing. It's where your parabola crosses the x-axis. As you can clearly see here, this parabola crosses at two spots, -5.317. It also crosses at 1.317. So what you'll notice a lot of times is the ones that don't factor are the x-intercepts are irrational solutions. They're these nasty decimals, so they're not integers, in other words. Okay, they're not going to be integers. So but they still exist. So we can't just act like they don't exist, and so we have a little bit of a problem. Well, introducing a new formula that we have to solve that problem. It's very useful when these things occur, and it's called the quadratic formula. The quadratic formula. So I'm going to go ahead and type that in there. There's no way you can go through algebra and not have heard about the quadratic formula. So let's title this thing real fast. I'm going to teach you guys how to use it. Quadratic formula. Why do we have the quadratic formula? Let's see if I can spell it right first. Yay, I did it. The purpose of it, frankly, is because sometimes you have functions like this that annoyingly don't factor. They don't factor. You can't find what multiplies the outside as the inside. You can't do the processes you've learned. So this is helpful because it always works. Let me say it again. It always works. You can use the quadratic formula for functions that do factor. Let's say you just don't like factoring. How many people out there just don't like factoring? Oh, you don't like it? You don't like it? You don't like it? Well, guess what? You can use this other method and it will always come it'll always come through for you, basically. It's like a big Honda, car, Toyota. It just always starts, it's just great. So we're going to go back to it, and I'm going to show you the quadratic formula. And I'll try not to sing. I'm going to really try not to sing, but I'm going to probably sing because it's the easiest way to remember the formula. So when I was first learning this, or even taking some courses on how to teach it, I remember they said, the kids will always remember this, so I'm going to do it this way. And it basically sounds like, I think it's Ring Around the Rosie or whatever. The quadratic formula, first off, it's x equals, okay? So x is going to equal this, and that's how you know it's the x-intercept. But it's -b. I'll probably write it, and then I'll probably sing it. All right? Then it's plus or minus. I'll explain to you what that means. The square root of, and then it's b squared minus 4 times a times c and all of this is being divided by 2a, okay, by 2a. So those of y'all watching the video, you might want to take a snapshot of this or take a screenshot of this. That is the formula. That's as good a handwriting as I can do, so you know, just do the best you can there. But here's how I was taught to sing it. You can say it one of two songs. You can find them on YouTube, to be honest with you. One of the songs is negative b plus or minus the square root of b squared minus 4ac all over 2a. I used to teach at a school. It was a little more urban, and they used to always go all over 2a, and they all like to do that. But anyway, that's one way you can kind of memorize it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That's what they used to do. Anyway, you got to figure out a way to memorize this formula because it's helpful, it's useful, and as I said before, it is trustworthy. It always works. Now, there's another song out there. I'm going to try not to sing it because there's a lot of falsetto out there, but it goes something like... I can't do it. It's bad. You'll look it up on YouTube. Maybe I'll leave a link to it in the description. You can check it out later. It's kind of funny, but it's another way you can remember this formula. But that's the formula, okay? That's the formula. Now, what in the world do I do with this? This is intimidating. Well, guys, don't forget your A, B, and C refer to the first coefficient, the middle coefficient, and the last constant on your quadratic. So the A for this particular problem, obviously, that's a 1x squared, so we say A is 1. That B is referring to the middle coefficient, so that's got to be a 4. And that C is referring to the constant at the end, your y-intercept. That's the negative 7. Okay, that's your A, B, and C. You get that directly from the trinomial, all right? Now, we're going to try to use this, and we're going to just kind of muddle through this together, all right? So remember, x equals all this. Negative b, I'm a big believer in put parentheses when you're substituting things in, especially when you got negative values. It really comes in handy. The b is 4, so I'm going to put negative 4 where that negative b would be, right? It's still plus or minus, so I'm going to say plus or minus. I'm going to do the square root of, here we go. We got to do another substitution, right? B is 4. So instead of b, I'm going to plug in 4 minus 4 squared, because that's b squared, minus 4ac. Now this 4 is part of the formula, right? There's a 4 in the formula, so I just leave that as is. ac, I'm substituting, so I'm putting more parentheses in there. The c, now watch this. The c is a negative 7. A negative 7. So be careful. That's why I like parentheses, because it helps me include the negative 7. All over 2a. All right, so there it is. So that's my first steps. I just want to use parentheses wherever I'm substituting in an A, a B, or a C, and I want to make sure I'm just watching my signs. I'm being very careful. Now, I highly suggest going through these problems the way I'm going to talk you through it. It'll help minimize mistakes. If you have a graphing calculator, there's a little trick I can give you, but here's how I do it. I start with over here where it says negative B. I'm going to go ahead and apply that. Negative times 4, well, that's just negative 4, right? So that's not too much thinking there, right? We're going to copy over the plus or minus and the square root of. Now, this part, you got to use your order of operations, and you got to almost think of that square root symbol kind of like parentheses, like a big parentheses, a big grouping symbol. I'm starting with everything in there, and I'm going across. Well, 4 squared is really equal to 16, parentheses exponents, right? And then when you see the minus 4ac, in fact, maybe I'll change the color so y'all can see this a little better, all right? I usually take everything here. I'm going to circle it so you guys can see it, including the minus sign. And I just look at that like one big multiplication issue. It usually cuts down my mistakes. So instead of thinking about like minus 4, I kind of take the minus, change it to a negative in my mind. And I look at that as negative 4 times 1, which of course is negative 4. And negative 4 times negative 7 is a positive. So that becomes plus 28. See what I did there? I look at that minus 4 as a negative, so I say negative 4 times 1, that's negative 4, and negative 4 times negative 7 is positive 28. When I write it in there, I have to put it as plus 28. That's the key, all right? And then I got to keep going. 2 times 1 is really 2, so I simplify that much. Y'all with me so far? Are we good? Are we good, people? Okay, I hope we're good. So now we keep going. This is under the square root sign, so it's kind of like I need to do that first, kind of like you would if it was parentheses. So we're going to add that up. 16 plus 28, what's that? 12 is 40 plus 4 more. I think that's 44. So I'm running out of room here, folks. So I'm just going to come out here to the left, okay? Copy it down. We got negative 4 plus or minus the square root of 44. Now here's where this is why you know it's a decimal, and I'll explain in just a minute, okay? But here's where we are so far, all right? Now, the square root of 44 is what we would normally have to tackle next. Some teachers, depending on what level you're at, are actually kind of happy when you just get to this point, and then they would say, here's your answer. There's no need to do anything else. This is as far as I want you to do right now, folks. And then some teachers want you to go all the way. I'm going to show you in this video how to go all the way with it, because I want you to see the connection between that solution here and obviously the solution where it would cross the x-axis at those points, okay? So 44, as you may have figured out or may not have figured out, is not a perfect square number. When I say a perfect square number, I'm talking about numbers like 16. The square root of 16 is 4. Why? Because 4 times 4 is 16, so it's kind of easier to do. Another perfect square example would be like 36. 6 times 6 equals 36, so the square root of 36 would be 6. That's an example. 100 is a perfect square. 64 is a perfect square. 49 would work, but 44 is not a perfect square. There's no whole number times itself that equals 44 exactly. Okay, so the only way to get the exact answer with these is you do need some sort of calculator or a cell phone. And if you type that into the calculator cell phone, if I type in the square root of 44 and I get a calculator, we're going to have to approximate it a little bit because there's a lot of repeating decimals. It's about 6.63. Okay, it's about 6.63. So I'm running out of room, but I'm going to do my best here. We're going to rewrite this just so I can help y'all see what I'm doing here. That's -4 plus or minus, and that really comes to, I'm rounding it a little bit, okay? That's about 6.6, what did I say? 6.63, I think I said. Okay, I'll stop it for right there. All over 2, right? Okay, so now that we've done this much, we're almost there. You can kind of see where we're going. That plus or minus, and forgive me, that's the ugliest plus you've ever seen. Isn't that pathetic? Anyway, I'm going to leave it, though, because I don't have time. So that's plus or minus. The reason it says plus or minus is because that's literally 2 operations that you have to do. You have to do -4 plus 6.63 divided by 2, and there's your first answer. And then you're going to do -4 minus 6.63 divided by 2, and that's going to be your other answer. Does that make sense? So if you need to see it, for those who are visual, we're literally going to do that twice. We're going to do -4 minus, or excuse me, plus, we'll start with that one, plus 6.63, all right? And then we're going to divide that by 2, and that'll give us one of our solutions. Remember, x-intercepts are going to have 2 solutions. Quadratics, I should say, rather, are going to have 2 solutions. So we're going to do a -4. We're going to add 6.63. This is going to be an approximation. Divide that by 2, right? And that should be about 1.31. Excuse me, about 1.31. So I'm going to put that here so you guys can see it for my visual folks. All right, so we know one of our x-intercepts, one of our zeros, solutions, whatever you want to call it, our roots would be 1.13. Now let's go to the Desmo so you can see real time what I'm talking about. Look at one of these intercepts. Is that not 1.31? I don't know why I said 1.3. See, is that not crossing at 1.31 approximately, you know, and some change? If I go to the problem, 1.31, you see we can do it by hand using the quadratic formula, or we can do it looking at a graph if we had the technology available, okay? So now that's one of our solutions is 1.31. I'll circle it so it stands out. You see it? You good? Okay, cool. So I'm going to erase what we just did so I can do it again where I'm subtracting, because that's one of our solutions. Now let's just do it where you're subtracting, okay? So now we're going to do minus. So we're going to do -4 minus 6.63, because it's plus or minus, right? See that over here? Plus or minus? You got to do both. And we're going to subtract it by 2. And we're going to do the math. We're going to put in our calculator, -4 minus 6.63 divided by 2. It should be about -5 or so. And I'll just kind of cheat and look here, but this is what it would be. It would be a -5.31 once you do the math. So I'm kind of cheating looking at Desmos, but you kind of get my point, okay? -5.31. So I'll write that in here. So the other one is x equals, what I say, -5.31. -5.31. That is it. Put a little equals there. So you should have 2 solutions. In other words, 2 points where the parabola that this function would form would be crossing the x-axis. They're decimals, and so that's just a little key. Usually it doesn't factor if it's not going to give you nice, pretty whole number parts where it crosses the x-axis, just like you see here in the Desmos, and that's what it is. So as the recap, this is the quadratic formula. It's your friend. I know it looks a little funny, but if you learn the song, -b plus or minus, or check the description below. If you check the description below, I'm going to have another funny song. I might make my kids at the Algebra 1 class watch it because it's kind of funny. A little violent, but I think it'll get their attention. We're going to burn the facts into their brain in a way where they just can't forget it. They might have nightmares, but hey, At least they remember their math. Isn't that what's important? I'm just joking a little bit. But anyway, that's what it is, guys. So tell me what you guys think in the comments below. Was that helpful? Is that weird? Are you glad that at least there's a video that you can go back and refer to? I'm glad we are. I'm going to make my Algebra 1 watch the video over and over because I have a feeling we're going to have to practice it. Remember, use parentheses when you're plugging in the A, B, and C values. It helps when it comes to negative numbers and not getting as confused. And the quadratic formula always works. It's sure and steady. It's dependable. It's a great thing to have in your toolbox, and so you can kind of get where you need to go, and you have the tools available to you. So anyway, that's all I got to say on today's video. As always, like, subscribe, share, click that notification bell for more content and analysis if you like what you heard, or if you feel like you would like some extra tutoring, or to sign up for our Algebra Made Simple 10-week program to help your kid who might be struggling in math. Maybe they weren't presented material in a fun and interesting way, and you want to galvanize their interest and their passion and not miss out on future learning opportunities. Message me. My email is in the description below. We'll put it up on the screen too, so you guys can get in contact with me and we'll work out a free strategy session. It'll be good. If not, you got this video, this content, share it with those who are in algebra class who might be struggling and need a little bit of a resource and a help. That's what this is all meant to be and meant to do. I love you guys. Have a blessed day. I'll catch you on the next one. Algebra Made Simple. Keep it simple.